So we're working on this packet here, and it has a little cartoon at the bottom, if you're still looking for it. This packet is not going to be on test 3. It's not going to be on this week's test, but it is material for the final exam. So don't really worry about it if you don't understand it like quite right now. But by the final, we should have a good grasp on it anyway. Okay, so I decided to make this section. This is like my favorite section because this is something that I kind of specialize in. It's something that I did a lot of research in grad school. And it kind of was like the idea of, well, what actually does it mean to be random, right? We throw this word random every single day in statistics class, right? We say that we have a random sample, or we're taking we're taking cards randomly out of a deck, but we don't know what that actually means. So what we started out with is, well, I told you that there were some things that generated random numbers that are actually truly random, that are actually true, like flipping a fair coin, or doing a thoroughly shuffled deck and picking out a card from it. Those things are truly random. And then there's other things that are pseudo-random because, well, they're not true random numbers. And, well, a lot of things use pseudo-random numbers, like protecting your Gmail password, or even like your car transmitting a signal to a traffic light or something like that. Okay, so most things actually do use pseudo-random numbers because, well, a computer can't actually flip a coin or take a card out of a deck. Okay, now, well, what does it actually mean to be random? We said that there were 2 things that went into being random, right? For example, flipping a fair coin. One thing that is really important to make sure that we have randomness is, well, it has to be unpredictable. You can't be able to figure out what the next number is, or the side of the coin you flip on, if you can predict it, right? It won't be random if you do that. The other thing is there has to be equal odds, right? A coin flip isn't random to determine what team starts, for example. If it's like a weighted coin where maybe you have a 75% chance of one team winning and 25% chance of the other team winning, because that's not equal, right? So the whole idea of random is, well, we have to have equal odds, and you're not going to be able to predict the next thing that happens. Okay, now, well, pseudo random numbers, those don't actually fit, oh my gosh, fit that description of being random. Okay, you can actually predict the next number when you do a pseudo random number generator. Okay, so I kind of gave you an example of a pseudo random number generator. This is one that I told you I just looked up online, and it gave some random numbers. The way I know it's pseudo random is, well, it doesn't say it's a true random number generator, and it's done on a computer. Usually those things are pseudo random. Okay, and I told you that there was some some notation. There we go. I'm getting back. I'm getting back on campus here, that you had to know. Whenever we have a bunch of numbers being generated at once, the first number is going to be x0, second number x1, x2, x3, x4, just to let you know, okay, this is the number in the sequence, right? Now, the first number of the whole sequence of numbers is called the seed because it kind of figures out, or it determines what the rest of the numbers are going to be, okay? Now, I gave you a very basic example of a pseudo random number generator, and it can be described using 2 processes. Okay, the first one's called an algorithm, and an algorithm is just like a list of steps that you follow. Okay, and I said, let the seed, or the first number in the sequence, be 10. Okay, multiply it by 2 and then add 1. Okay, after you do that, that number is the first number in your sequence, and then you just repeat it over and over again. Okay, so multiply by 2, add 1, multiply by 2, add 1. Okay, now the way you can write that in terms of an equation is by saying the next number is 2 times the current number plus 1, right? Multiply by 2, add 1. I called it a recursive formula. You don't have to know that, but, well, there it is. Okay, well, we use that whole process to come up with a sequence of numbers, right? We started with 10. Our next number was 21, 43, 87, 175, 351, and so on. This became our sequence of numbers. Okay, so this is actually how computers generate random numbers. Okay, but the problem is, well, when I did my first random number generator, I told the number generator that I wanted my numbers to be between 1 and 13, right? So all of these numbers, x0, x2, x4, all of these numbers are numbers between 1 and 13. Well, look at our sequence that we generated. 10, well, that's between 1 and 13, but then we have 21, 43, 87. Oh gosh, now we're just getting bigger and bigger and bigger and bigger and bigger. And it makes sense because if I take a number and multiply it by 2 and add 1, that number has to be bigger, right? There's no way it can get smaller if I'm doing those things, okay? So what I'm going to do today is I'm going to show you a trick that mathematicians use to create a sequence of numbers and make sure that all the numbers are between like 0 and 10 or 0 and 15, something like that, okay? And what we call it is clock arithmetic, okay? Oh gosh. Anyone know, like, anyone heard of like military time? Yeah, right? What clock arithmetic is it's literally doing military time. And let me just kind of explain to you what this is, okay? Let's say we have a 12-hour clock, okay? So 12 things on the clock. And let's say we left home at 9 o'clock. Don't worry about AM or PM. We're not doing that, okay? And we're returning 4 hours later. Okay, well, I want to know what time it is. So I do 9 plus 4, 9, 10, 11, 12, 13. Okay, but is 13 o'clock a thing?
Well, 13 hours.
In military time, yes, it is. But
So that means 1 o'clock for real.
it means 1 o'clock, right? 13 o'clock is the same thing as 1 o'clock. Now, don't worry about AM or PM. We're not worrying about that. Okay, so 13 o'clock, same thing as 1 o'clock, right? So it's kind of a way to take a number bigger than 12 and turn it into a number smaller than 12, right? Okay. Now let me just show you the algorithm I use to do this. Now you don't have to think about it this way, but to go from 13 o'clock to 1 o'clock, what you really do is you subtract 12, right? So subtract 12 from 13, and it makes it a number between 0 and, oh my gosh, well, 0 and 11 or 1 and 12. Okay. How about this? I have two other examples. The second example is kind of tricky, but I think you'll be able to figure it out. Why don't you do the next two and I'll come back in a bit. Example, we left home at 11 and we returned 5 hours later. So I'm really doing 11 plus 5, right? And that gives me 16, right? Now 16, that's not between 0 and 12, right? So, well, if you subtract 12, what do we get? 4 o'clock. And well, that's a number between 0 and 12. That's something that we want. So it's really 4 o'clock. Even though it's 16 o'clock, 4 o'clock conveys the same thing. We're just talking about, well, a different time, well, different way of telling time, right? Okay. The third one's a little bit more tricky. Okay. Let's say we left at 11 o'clock and returned home 20 hours later. Well, 11 plus 20, that's 31. Okay. Well, let's do the same thing, right? We said subtract 12. 31, what's 31 minus 12? 19. Well, 19 o'clock doesn't make sense either, right? Unless you're in military time. What should I do now? Subtract 12 again, right? I can subtract 12 again, and that gives me 7 o'clock. And that's a number that I like. That's a number that makes sense on the clock. So what we really did is we subtracted 12 to get a number. It's not what we want, so we just subtract 12 again, and then that gives me the number that I really want, okay? So this isn't really military time anymore because we're starting at like 31 o'clock. I don't think military time counts.
Makes sense. No, 24, 12 hours, 31 o'clock doesn't make sense.
Yeah, that doesn't make sense, right? But you can just do the same process twice and then you get the number that you want. Okay, so let me tell you the term that mathematicians use to describe this whole process. We don't call it military time because mathematicians are just, well, we like names for things. We like making things a little bit more complicated than they should be. So let me just show you, if you flip the page, I'll just take each of these things that I did and tell you how we do this. Okay, so mathematicians, we call this process a modulo operation. Has anyone heard of this before? Yeah, I feel like if you have any friends that are like in computer science, they use modulo a lot. It's kind of a trick to get a number smaller but mean the same thing. Another way to say it is a mod. Okay, so modulo, mod, that's what we mean. Okay, and when we talk about a modulo operation, okay, so operation is just like adding, subtracting, whatever. Okay, what this does is it takes a number and it makes it smaller, and in particular, it makes it one of the numbers between, well, in this case, 0 and not 12, but 11. Okay, so if we're doing a modulo 12 operation, like we did before, the only numbers we can get are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Okay, why wouldn't 12 make sense with a mod operation?
Because the last
Well, if I try to do 12 and do the subtracting 12 thing again, what's 12 minus 12? 0, right? So isn't 12 the same thing as 0, right? And then 13 is the same thing as 1. 14 is the same thing as 2. 15, 16, 17, 18, 19, 20. So basically what you do is you take a number and you subtract 12 in this case over and over and over again until you get either 0, a number between 0 and 12. Does that kind of make sense? Okay, if it doesn't, I promise we'll do a lot more practice with this, so don't worry yet. What you're gonna do is you're gonna subtract 12 over and over again until you get a number that's either 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or 11. Okay, but 12 doesn't count. Okay, so let me just take each of these things that we worked on the last page, and I'll show you how to write it using mathematical terms. If you don't get it right now, I promise we'll do a lot more practice with this, so you don't worry about it. But let me just show you, well, what we did. Okay, so the first question we did on the last page, we said, let's say it's 9 o'clock, and I add 4 hours to it, okay? Now, well, 9 plus 4 is 13, right? Now, I need to mathematically write that I'm subtracting 12 over and over again until I get a number that I want. So this is how we do it, okay? In parentheses after 13, we're gonna do this, mod 12. And we read it exactly how it's written, 13 mod 12. Okay. It's short for modulo. So modulo is saying subtract 12 over and over again until you get a number between 0 and 11. So it's kind of like addition, subtraction, multiplication. It's an operation. We just call it mod. Yeah. And then when we subtracted 12 from 13, well, we got 1. Okay. So 13 mod 12 is equal to 1. Okay, same thing with the other two. We did 11 plus 5 hours. 11 plus 5 is 16. Mod 12, we said was 4. Okay. And then we said 11 plus 20, that was our big one, 31 mod 12. Well, we said that was 7, right? Okay, so this is just the notation that we use. Whenever we write mod 12 in parentheses after a number, it's just telling us subtract 12 over and over again until you get a number between 0 and 11. Okay, does that kind of make sense? Okay, if it doesn't, don't worry, we will make sure.
So instead of minus 12 or however many times, we just put mod.
Yeah. Okay, now I'm going to make it a little bit more complicated. Okay, let's pretend in military time, we don't have a clock that goes from 1 to 12. Let's say we have a clock that goes from 1 to 10. So maybe we have a clock that looks like this. Why don't we do some mods with this clock instead of a 12 clock? Okay, now if we're doing a 10 clock instead of a 12 clock, guess what our mod's going to be? Mod 10, right? So this is how we're writing it after we do our operation, okay? And what numbers do you think are going to work as our answers this time? 1 to 9, but will 0 count? Yeah, 0 will also count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and also 0 will count as our answer. 10 won't be an answer because, well, 10 counts as 0, right? And well, anything bigger than 10, we'll just subtract 10 from it to make it fit. Okay, why don't I do a couple of these with you and I'll let you do some of these on your own. 7 plus 6 mod 10. Well, 7 plus 6 is really 13. So, well, what do I have to do to get 13 mod 10? Subtract 10, right? So 13 minus 10 is 3. All right, so 7 plus 6 mod 10 is 13 mod 10. That's 3. 4 plus 7 mod 10 is 11. Okay, what's 11 mod 10? 1, perfect. Okay, why don't you do the last two? They're a little harder, but try this one on you. All right, what's 18 plus 64? 82. If I want to do 82 mod 10, well, you subtract 10 to get 72, subtract 10 to get 62, subtract 10 to get 52. What do you think 82 mod 10 is? 2, perfect. And let's do 34 plus 5. What is 34 plus 32 plus 5? Sorry. 37. And what do you think 37 mod 10 is? 7. Was this a lot easier than the mod 12?
Yeah.
Why do you think mod 10 is easier than mod 12?
Because you pretty much just take away the tens place.
You basically take away the tens place. Actually, we live in this world that we call a base 10 number system world. Has anyone heard of like bases in math?
Oh yeah, was taught that last semester.
Yeah, I think a lot of you have taken a math class where you had to learn about all the bases, right? Now, base 10 is basically the number system that we live in, okay? We have 10 fingers, right? Our number system, or when we count money, we go by tens. It's actually really easy for us to do mod 10 because, well, we live in this world where we do it all the time, okay? Now, other bases are a little bit harder because, well, we don't live in that world anymore. But, well, base 10 is pretty easy. Okay, well, why don't we do a few more, okay? Let's do a couple different mods with different bases, okay? What we're essentially doing is changing the number system that we live in, okay? All right, let me do the first two for you. The first one says mod 5, okay? When we're living mod 5, what are the possible answers that we can get? 0 through what number?
4.
Yep, 0, 1, 2, 3, and 4 are the possible answers here. When we do 3 plus 12, we get 15, okay? And if I want to do mod 5, well, I subtract 5 and get 10, subtract 5 and get 5. What is 15 mod 5? I hear 2 different answers.
Sorry, no, I'm ready.
Oh, 0. I get 0, right? So 15 minus 5 is 10, minus 5 is 5, 5 minus 5 is 0. Perfect. Okay,
You
for
subtract it 3 times.
yeah, I had to subtract it 3 times. 14 plus 2 is 16. This time I'm doing mod 3, so the only answers I can get are 0, 1, and 2, right? Okay, let me write that up here. 0, 1, and 2. Well, we have to do 16 minus 3. Oh God, I can't do this in my head. To get 13. 13 minus 3 is 10. 10 minus 3 is 7. There we go. 7 minus 3 is 4. And 4 minus 3 is 1. That's a number that we want. Okay.
Subtracted 4 or 5.
Oh God.
I'm sorry. I just
16. Is it 5?
3 times.
Oh yeah. Okay.
So
Yeah, I see that. So to figure out how many times you have to subtract it, well, 3 times 5 is 15. That's the smallest number below 16. So you'd have to subtract it 5 times. I'm smart. You know what? Sometimes I think that I I am not good at arithmetic. So when I was a math major, everyone could do that in their head. And they're like, oh, this is divisible by 11. This is divisible by 12. And I'm like, oh. Right, why don't we come back together here? And let's just do some of these. I think I forgot that you all took a class on number bases. So I think I think you're all pretty used to the topic anyway. Let's just do a few more of these. 11 plus 1. Well, 11 plus 1 is 12. Mod 17 means the numbers that we want are between 0 and 16, right? Is 12 between 0 and 16? So do I actually have to subtract 17? No, right? I can just leave it alone. You don't need to do anything because 12 is a number that I actually want, right? It's between 0 and 16. Cool. Yeah. So you don't actually need to do anything if the number is what you want, right? For example, if it's 4 a.m. in military time, it's still 4 a.m. You don't need to do anything to change it, right? All right. 12 plus 15, that's 27, right? What are we getting 27 mod 20? 7, right? Because we just subtract 20 and we get 7. Okay. 2 plus 7 is 9. Oh gosh, we have to subtract a couple times here, right? 9 minus 2 is 7. 7 minus 2 is 5. Oh my goodness, this is embarrassing. 5 minus 2 is 3. Is 3 my final answer? No. What do I have to do? Subtract once more to get 1. Perfect. So 9 mod 2 is actually 1. Okay. 9 plus 12 is 21. We're doing mod 11, so our numbers can be between 0 and 10 this time. So 21 minus 11 is 10, and that's a number that we want. So that's our answer. Okay. You know what? I think we're doing pretty good with these. I thought this would take a little bit more time to explain, but I think we're all good with doing these mod operations. I know it looks weird because we're just using parentheses, like usually mathematicians use like plus minus signs and stuff like that. But it's basically just subtracting until we get a number that we want. Okay, and that's all we have to do. Okay, so you're probably wondering, well, what does clock math have anything to do with these random number generators, right? Why do we care about bases or numbers or whatever when we're doing a random number generator? Well, let me tell you. Okay, now when we did our random number generator before and we were like calculating numbers to generate here, all our numbers were increasing, right? Well, what if I want a number between like 0 and 12 or something like that, right? Well, maybe I could do a mod operation on each of these and actually get a number that we want, okay? So why don't we go ahead and do that? Okay, this time, let's say I want a number between 0 and 12, which means we have to do a mod 13. Okay, here I have a clock that has 13 rings instead of 12. Does anyone know the movie this came from? Huh? No, but it's kind of close. It is a musical. Does anyone watch Labyrinth? Yeah, I got this from the movie Labyrinth. There it used a 13-hour clock instead of a 12-hour clock, which I thought was kind of cool. I don't know, maybe that's just me being a nerd. Yeah, it was like an extra hour for Sarah to complete her quest. Now I just sound like a complete nerd. Oh God. Yeah. It would, right? I don't know why it's 12. I think it's just like ancient. I think it's always been 12. Yeah, I think it's something to do. Yeah, that's a good question. I have no idea why it's 12. I never thought about this. Yeah, I don't like 13. I don't like 13 at all. Yeah. I like even numbers way better than odd numbers. I don't know why.
Maybe because it could be divisible by 2.
Yeah. Does anyone, when I was a kid, you know that phobia that like makes you scared of the number 13? I actually had that phobia. I was so scared of the number 13. Like I wouldn't look at a clock if it was like 113, like I would look away until it was 114.
It's
Yeah.
terrible.
I was honestly like super scared of the number 13. I don't know why. Okay, but I digress. We're doing mod 13 for this example, okay, which means the numbers that I want to generate are going to be between 0 through 12, right? Okay. Well, why don't we do this? Why don't we use the same number generator, multiply by 2 and add 1, but I'm going to add something else to it. mod 13. Okay, so when we're doing this number generator, we're going to do the same thing. Let's start with the same number. We're starting with 10. Okay, we're going to multiply by 2. So that would give us 20. Okay, we would add 1 to give it 21. And then at the end, we're going to do the clock math thing to do mod 13 so that our number is actually between 12, 0 and 12. Okay, so hopefully that makes sense. Why don't we do, well, go through a few of these. You might be wondering why we're going to do this a lot. I have a point, I promise. I'm not just making you do busy work. But why don't we just go ahead and do this, okay? By the way, if you're confused by the terms here, xi plus 1 is just representing the next number. Okay, xi represents the current number. Okay. Okay, I don't want you to get too confused with like the symbols and everything. It's just telling you to multiply 2, add 1, and then do mod 13. Okay, well, why don't we start with this? Our first number in our sequence x0 is 10, right? If I want to calculate x1 or the next number in my sequence, I'm going to do 10 times 2 plus 1, right? Well, that's 21, right? But then 21 isn't a number that I want. I want all my numbers to be between 0 and 12. So we're going to hit it with the mod 13. Okay. Okay. What is 21 minus 13? 8. Is 8 between 0 and 12? Good. So we don't have to do anything. 21 mod 13 is 8. Okay. So our next number in the sequence is actually a number between 0 and 12. It's not any bigger than 10. Okay. So my next number is 8. Okay. Guess what I'm going to do next? 8 times 2 plus 1. Perfect. And that gives me 17. What's 17 mod 13? 4. Perfect. And then, well, my third number in my sequence is 4, right? So we have 10, 8, and 4. Okay. My next number is 4. 4 times 2 plus 1 is 9, right? What's 9 mod 13? Just 9 because, well, 9 is a number that we want, so we don't have to do anything to it. Okay. Now, I know I have a lot of error or rungs to this chart. It even goes onto the back page. I promise you, I have a point as to why you're doing so many calculations. Why don't we?
Is fun? Stop it.
I don't. It's fun for me, but it's probably not as fun for you guys. Why don't you work? Yeah, it is easy. Why don't you work through this? Go through the rest. It's actually not too hard. You can write out all the calculations like me, or you can just go on. I'll make sure you're on the right track. I promise I have a point as to why you're doing these calculations, okay? So let's come back in a little bit. All right, some of you I swear are like speed demons. Okay, what I'm going to do here is I'm not going to show you each of like the steps here because I think we're on the right page. And as I'm walking around, everyone's doing really good calculations here. What's the number that came after 9? 6. What was after 6? 0. After that? 1. After 1, what did we get? 3. After that? 7. 2. 5. 11, 10, 8. Perfect. Okay. I know that a lot of you are still working on this. I kind of just want to make sure we finish before class ends. But these are the rest of the numbers we got. And as I was walking around, I think everyone was doing the correct calculation. So I don't think I'm too worried about that. But this is the rest of our sequence. Okay. So what we actually did is we calculated 11 extra parts of our sequence. So I know it's kind of hard to look at with the chart. Why don't I just write out our sequence of random numbers that we got, okay? We started out with 10, that was x0, we call it the seed, it's the first number in the sequence. After that, we got 8, 4, 9, 6, 0, 1, 3, 7, 2, 5. After 5, we got 11, 10, and 8. Okay. So this is a sequence of random numbers and it looks a lot better than, well, what we had before, because all our numbers are between, well, 0 and 12, which is really nice, right? We want all our numbers to fit that description, okay? Does anyone notice anything bad about the sequence? It's about to repeat. So I like what Cassidy said. Look at what happens when we hit 10. The next number is 8. What do you think is going to be the next number in the sequence? 4, 9, 6, 0, 1, 3, 7, 2, 5, 11. Right. So this is an example of a random number generator. It is good that it generates random numbers and it's between the numbers that we want, but it's not that great of a random number generator because, yeah, once you see the pattern, it becomes really easy to determine, okay, well, I know what's going to happen next because, well, the next number in the sequence is just going to be repeating. Okay. So, well, what we did is the reason this one repeats is because, well, this is kind of a bad random number generator. It was a very simple way of doing it, right? We just multiplied by 2 and add 1, and then we did mod 13. Okay. Now, I'm going to tell you, whenever we do mods, there actually is always going to be some sort of repetition going on. Okay. We can't really go away from it, okay. Which is why most of the times, like protecting your Gmail password, all those applications like models, all that stuff, we use mods that are way higher than 13. Okay, so usually there's no element of repetition if you make the mod high enough. Okay, another thing we do is we don't use a simple mathematical formula like this. Okay, usually it's not just multiply by 2 and add 1. Usually there's a lot of different mathematical symbols going on in there. Instead of just multiplication and addition, right? That usually just doesn't really happen in real life. Okay. The last thing that I want to talk about is the seed. Okay. 10 is the number that we started with, and it determined the rest of the sequence. What a lot of mathematicians will do out in real life when they want to create random numbers is when it just is about to repeat, what they'll do is they'll change the seed to maybe 12 or 3 or something like that. So then maybe it repeats, but it's repeating in a different sequence. Okay. So by changing the seed, you can actually get a different sequence of numbers, if that makes sense. Okay. So I don't know. I kind of gave you a bad example of a random number generator, but I'm going to be honest, these things get really, really complicated very fast. Okay. So I think this kind of gives you an idea of how random number generators are actually created. Usually examples in like statistics classes, we don't actually use random numbers. Okay, we use these pseudo random numbers. They're really easy to create. I kind of put something up here if you want to read about it. But yeah, this is how random numbers are created. All right. Any questions on random numbers? Okay. What I'll do is I don't actually know how I'm going to test you on this on the final. I'll come up with something, but I'll make sure that you'll be prepared for a question on this stuff. I know it's kind of abstract. I'll make sure you understand any sort of test question on this in the future, but
Maybe something like